This video goes along with modules 8 and 9 in your book. We will discuss Earth's atmosphere, watersheds, solar radiation and Earth's seasons, and Earth's geography and climate. We'll start off with talking about disturbances and watersheds. This module 8 is a little bit of a hodgepodge of topics, but a disturbance is an event that causes changes in a population size or community composition. It could be caused by hurricanes, storms, tsunamis, tornadoes, volcanic eruptions, or forest fires. Not all disturbances are bad. When we get into forestry in the next unit, we will see that fires can be beneficial to areas. So it could be a good disturbance, even if it causes some damage. Resistance is the measure of how much a disturbance affects flows of energy and matter. Resilience is that rate at which an ecosystem returns to its original state. The downside is that anthropogenic disturbances can eliminate ecosystems, and that is a bad thing. We can use watershed studies to help us understand how disturbances affect ecosystem processes. A watershed is all land in an area that drains into a stream, river, lake, or wetland. And these are great for conducting studies. The intermediate disturbance hypothesis says that ecosystems experiencing intermediate levels of disturbance are more diverse than those with high or low disturbance levels, which we can see with those graphs there on the right. Areas with low disturbances experience intense competition. And we know that organisms competing for the same resource are unlikely to be able to survive and thrive together. So we want intermediate levels disturbance to have the maximum amount of biodiversity. Earth's atmosphere is composed of 5 layers. The troposphere is the one that's closest to the Earth's surface, and it is about 16 kilometers from the ground, about 16 kilometers up. The stratosphere is above the troposphere, and then there's the mesosphere, thermosphere, and exosphere. If you take a look at the graph on the right, you will see that the temperatures change dramatically between each layer. So we have increases and decreases, and then increases, and then exponential increase as you go through the thermosphere. The amount of solar energy that reaches the Earth varies, and that is because warming from the sun is not distributed evenly across the planet, and that is because of the Earth's slight tilt and its spherical shape. So the equator gets the most direct sunlight, and solar energy is less direct at mid-latitudes and polar regions because it takes longer for the light to reach the surface, which you can see from the diagram there. Albedo is a percentage of incoming sunlight that is reflected from a surface. If it is higher, we have more energy reflected and less that is being absorbed, which we can see here. Forests are about 10 to 20%. Snow was between 80 and 95. So you can see there's lots of differences in how much albedo it has per different areas. Earth's tilt causes seasonal changes in climate. So we have the March equinox, December solstice, September equinox, and then the June solstice. And that will dictate what season the hemisphere is experiencing. Here, the March equinox we generally call the spring equinox, but that is not the most appropriate term to use because it is spring for us, but it is not spring for other places. So an equinox means that there are about the same number of hours of daylight and darkness. At the solstices, it's either the longest day of the year or the shortest day of the year, depending on where you are. So you can see that as the Earth rotates around the sun, we have changes in the tilt, which will lead to us having different seasons. Where we live, we do experience 4 relatively distinct seasons, although sometimes it feels like they all muddle together, but there's going to be less seasonal change as you get closer to the equator and also farther away from the equator.